welcome back to my report for correlation and regression in R. So today I'm going to show you some useful command before we dive into the actual correlation analysis uh, using R. So the first thing that we're gonna have to do when we are working with R is to set up our working directory. So to do that, we can use the function setwd, and inside the parentheses as the path or the location of our file where our data are located in our computer. So in order for us to work on it, we have the R has to look for the pathway where your data are located in your computer. So to do that, you can actually use the function setwd, but if you don't know the code, you can do that manually using the top menu, and then you choose the session and then set working directory, and then you choose the directory, and then you navigate the folder where your files are located. After you set it up, you have to install a package or, or some packages. So um, for me, I want to install the reader package using the function install.packages, and then followed by the parentheses, and inside the parentheses double quote, and then you put on the name of the package, which is a reader. So what is a reader package? So reader package is a package that let you read your CSV file or any format of any files that you want to work with. So if you don't install this one, you won't be able to read or import your files in R. So you have to do that. And then once you install that, so we have already installed that, but if you haven't done, so you can actually run this one over here. But if I have already done that, so I have to load that up in my R library. So using the function library, and inside the parentheses the name of the package without double quotation. So I want to run this one to access this reader library before I import the data file that I want to work with. I have created 3 data file or data sets for the purpose of showing you some useful information or command for correlation and regression analysis. To do that, I use the read underscore CSV function, and within the open and close parentheses and double quotes is the name of the data that I want to import. So that for me, it's a sample data.csv. It's CSV made in Excel. So I want to install to import sample data.csv using the command read underscore CSV, and then save it in my R environment as a demo1. So then I want to save another one, which is demo2 and then demo3. So if I run this one, just click on any uh, of the space within the line where your command is located, and then just click run over here, and then it will give you the result on the bottom window, which is the terminal window, and then I'll do it again for the demo2, and then I'll do it for the demo3. And as you can see on the right panel here, on the global environment, we have already imported or successfully imported the 3 datasets that I have just created. So if I print, for example, the print demo1 will just going to show you the what type or what the data that you have just imported. So if I run this one, so we're just going to show you just a bit of information of what the data looks like in this form. But you can actually have a look on this one in a tabular format. So you have to just go back on here on the global environment and just click whatever you want to, whatever data set you want to look at. So for example, I want to look for the demo1, and as you can see, it will pop up on the console editor panel, and we'll show you in tabular format. So I have the ID here, species variable, the sex one, the length, weight, and age variables over here. So in R, if we calculate the correlation and regression analysis, sometimes we don't need too much information. that we want to include in our correlation analysis. For example, this ID column over here, we don't need that for a correlation analysis. We can actually ignore that or drop that column using the function null or null. So that means that this function will, or when we run the correlation analysis, this function will ignore the ID column in the correlation analysis. So we just have to type in the name of the data set and then the $sign and then the name of the variable, which is the ID, and then you use this symbol over here, and then you just type in null or null. If we run this one, so this means we have excluded the ID column in our analysis of correlation. Next one is, as I have said earlier about my presentation, for the correlation, we use the quantitative variables, but go back to the table over here, we can see that the sex variable has two categorical variable or categorical type of data, which is male and female. M stands for male and F stands for female. So we want to change that into something numerical so that when we calculate it in R using a correlation analysis, the R will not give us an error because, as I've said, correlation needs two quantitative data. So we can use this function over here, as well as one, and of course we just type in whatever over here, the blue one, whatever name that we want or whatever value that we want to use as a replacement for the variable f female. For example, I want to replace the f as numerical value of 1, and I want to assign 0 for the male variable. So if I click this one, just put your cursor over there and just click run, and then the other one. So we go back on our table, and as you can see, we have already successfully changed the sex variable type of data over here. So 0 means male and 1 means female. These are already numerical. And as you can see as well that we have already dropped the column for ID, so it's no longer available for correlation analysis, will be included in there, or not be included in the analysis. But sometimes the number doesn't always tell us that it is indeed a numeric value. We can actually assign a particular class to a particular variable. For example, we're not sure if 0 and 1 is a numeric type of data, but to make sure, we can actually assign or convert that one into something numeric using the function as dot numeric, and parenthesis is inside the parenthesis is the name of the dataset, which is the demo one, and then the $sign and the name of the variable, which is the sex. And I will click this one. So that means I have already successfully changed the, just to make sure that I have changed the variable male and female into something numeric. So if I use this one as apply function, it will show you the type of the data class that you have in your variables. So for example, for a species, I have numeric already. The sex has numeric, and the length and weight and age, all of them has numeric. Let's say I want to change it again from numeric into a character or a class. So just run this one. I'm going to run this one, so just let it be like that. So let's say I want to change the weight into a integer. So I can use the function as int.integer. So what is the difference between the numeric and integer? So numeric holds decimal points, and integer holds no decimal point. For example, age has no decimal point, so age should be integer class. If we want to convert all the variables to one class in just in one column, or let's say we don't want to do it one by one, we can actually assign or specify columns that we want to change using this function over here. It tells us about how many columns that we have. Just type it in there, and then we can use the function here and run it. If we want to change all the characters or the class type into numeric, so I'll use this as that numeric function. So I don't need to run this one because I have already run it. But we're just moving forward on correlation analysis. So as you can see, I have here a missing value. Let's see. So here, the observation 12, I have a missing value for length. So in our correlation, as I've said earlier, that in order for us to go through the correlation analysis, the samples must be paired. So there's a missing value in there, so it definitely is not paired samples. So if we run a correlation between the length, for example, and weight, we want to know the relationship between these two variables over here, we can use the function that ZOR, and then within the parentheses you can do it. Like put on this argument over here. Let's put on the of course the data set, and then the dollar sign is very important in there, and then the name of the variables, and then followed by the comma, and then the other variable on the other side. And then if we run this one, it will actually give us an NA value of correlation coefficient. So why NA? Because we have a missing value or a missing data in there. The missing data could be as a result of course, maybe there's no measurement, or there's a typo error or something like that. But yeah, the core function will tell us that there is an int-a, or a not available value in there. So there's no available for correlation analysis to do that because we have a missing value. In order for us to successfully do the correlation by ignoring the missing value, we can use the same function at the top over here, and then just add the use equal complete OBS. So that's complete dot observation. So if we run this one, and as you can see the correlation coefficient of 0.9837. So from there you can conclude that there is a relationship between this. There is a strong correlation between the two variables, between the length and weight. If we want to have a look in the tabular format of the correlation coefficient, we can run the function core, and then within the parentheses it's a demo1 data set. But since we have a missing value, so definitely all the length data over here will be assigned with an int-a value as well, or result. To actually remove the entire row, that's row 12, so removing the entire row 12 in our analysis of the correlation, we can use the pairwise that complete dot obs function. So if we run this one, and let's see and compare this to tabular format correlation coefficient result. So you can see that in here the length has been replaced bottom here with the actual value of the correlation coefficient. It's just because that entire row number 12 has already been omitted from the correlation analysis. So before we actually begin our correlation analysis, we have to make a few assumptions about, like, if we have already met all the assumptions for the analysis of the correlation. One of the assumptions is that there should be a linear relationship in our data. So to visualize a linear relationship in our data, we can use the plot function, or we can use a scatter plot to have a look if there is a relationship, a linear relationship among the two variables that we want to uh, uh, analyze. So we can use the function plot and then open and close parentheses and just put on this information over here. So the length and weight are the two variables that uh, we want to measure the relationship. And the data is the name of the data set. So the main here is just a name that we want to name for our scatter plot. And the x lab is the name of the x-axis, and y lab is the name of the y-axis. So if I run this one, I should be able to see over here the result of the So you can see that this scatter plot is showing the data points in linear, some sort of a linear relationship. So because it's moving up over here, so direction is going up. It seems like if you put on the regression, the line over here, the trend line, I expect that all the data points are somehow not deviate away from the line over here at the middle. Okay, so sometimes we want to have a look how many or what are the data set that we have already in our current workspace in R. So we can use the function ls and then inside and then close and open parentheses. That means that I have already 3 data sets that I've imported in my current global environment, in my current workspace. Now I want to, let's say I want to remove demo 1, demo 2, and demo 3 from my global environment, from my current workspace. So I can use the function rm and then open and close parentheses with the double quotation marks inside it, and then just type in the name of the dataset that you want to remove. Let's say I want to remove the demo one, so I can click the run over here, demo one. So that means I have already removed the dataset demo one. I want to remove multiple datasets in one command, so I just run this command over here, rm, double quotation marks, dataset separated by commas. So if I run this one, demo 3 and demo 2 removed from the from our current workspace. You can always import that using the read_csv form function. Okay, one last thing about it that I want to show you is the listed package that we have already installed in our current workspace. So this function dot packages and then open and close parentheses. If you run this one, it will show you the packages that you have installed in your current workspace. So it will be quite helpful for you to look into how many of the packages that you have already installed in it. All you have to do is just load it up in your library and you're ready to go. All right, thank you for listening, and we'll go on the next my next report about the actual correlation analysis of the data that we have received from our instructor. Thank you, and God bless.